Great. So to introduce our next talk, we're going to have Juan from Zondax. He's going to be showing a presentation and running a panel on metadata protocols for offline signers. So we'll welcome Juan on the stage, and we'll get started.
So we are here to present something that has it brought a bit of controversy online, and there has been a lot of discussions about these things. And we are going to talk about like how verifiable metadata for offline signers is like super important. Over time, So first, I'm going to give an introduction. Then I will invite someone else from my team to give an update on how we have made some progress, well, really good progress, you will see. And then we will discuss a bit of the technical details. The idea is that we want the community to also kind of contribute and answer questions. So we will have a panel after that for Q&A. Just as an introduction, so you know a bit like better what Zondax does, because we have been like behind the scenes many ecosystems for the last few years, but typically we are not so user facing kind of like provider or company. We do a lot of the security and cryptography for at least 40 chains, like mostly top L1s. We have delivered like a lot of projects. Typically, we work mostly on the backend side of things, so security, cryptography, protocol engineering, and we are also kind of doing some work on data infrastructure. We have on-prem services and servers, so it's much broader than basically security and cryptography, but in the ecosystem, in the Polkadot ecosystem, we have been like really much working in that space. So where do we come from with respect to ledger apps and offline signers? So we started with Polkadot like back in 2019. We developed and we have been like maintaining ledger apps for Polkadot, Kusama, StateMint, and StateMine since then, and also for most of the parachains. By the time that Web3 launched the crowd loan programs, there were like winners for the program, and Web3 decided to reward any winner of a crowd loan with ledger apps that were restricted because of like the diversity and the kind of innovation that was expected from parachains. But at least it was enough for people to, for basic users to have transfers between them. But parachains started to innovate. Pallets and upgrades started to flourish, and that meant that there was a lot of variations in the ledger apps that were necessary. At that point in time, also, parachains were like kind of like very active, and there was a lot of funding. So every parachain for differentiation wanted to have their own ledger app. That meant that there were a lot of things that we had to kind of like submit to Ledger, and there was a lot of upgrades happening. So the problem is that innovation brought a lot of breaking changes. I mean, now things have improved like quite a lot with Polkadot V1, but the situation is that when pallets, because of the design of how the runtime works, when pallets were like being modified, we had to kind of like make modifications on the apps. The reason is that the structure of the metadata was changing. The metadata is basically, I will not go too much into details right now because we have the technical part, but the metadata is like what is describing how the transaction should look on a ledger device or in any offline signer where you really want to verify what you're signing. And that meant that basically we were like practically releasing every 3 weeks for Kusama and every 6 weeks for Polkadot new upgrades, and that was like kind of like a really high pace of like development. The problem is that, obviously, it's not bear market only, but obviously the ecosystem started to suffer with so many upgrades. And there were additional requirements over time about external audits on this. So that meant that there was an additional cost on every time a parachain or a relay chain was making updates to a runtime. So for you to understand how a ledger app process, and this is kind of like similar, maybe not always as restrictive, but it's similar for most of situations where you need to do offline signing. That means not just like final users, but also exchanges. Typically, the thing goes from we have to do development and testing. That's kind of like standard software development practices. But the fact is that when we make a submission, Ledger needs to have some initial release that is a development mode release that is prioritized based on certain factors, like number of users and some priorities that Ledger has. Because of the high amount of parachains that were being released at that point in time, there was a prioritization, and not everyone was getting even into development mode. But the challenge was about how to exit development mode, because the thing is you had to go and pay an external audit, which has an additional cost. And then there was an internal review, functional review, that to test that it was actually feasible for users to understand what's going on, even in some cases when parachains were quite technical. And then it was the public release. What we've seen in the last year and a half was that many chains did not manage to get to the public release stage. That was for different reasons, like prioritization, external audits. But the fact is, it was very hard for that to happen. And that resulted in a lot of struggle. Obviously, the situation is that in a bear market, everyone wants to have some exposure, and that was not possible. And obviously, that generated some frictions. So what is the path forward that we have been working on? And later, during the panel or the technical discussion, we can explain a bit more the reasoning of why this has been so difficult. Is that we are currently developing a new Ledger app that depends on verifiable metadata. The idea is that, at least in my opinion, I have not seen anything similar in other ecosystems. We have verifiable ABIs that can be verified at the node level. So that meant parity had to be involved. And then we also have a way for that verifiable metadata to be streamed into the app. So the app needs to be kind of changed so it can be generic. And there are going to be, once this gets complete, there are going to be kind of very minimal updates to the runtimes of the parachains and minimal updates to the wallets, so we can stream these metadata for kind of showing actually what is the purpose of the transaction that you are signing. The last stage will be audits. So it's a kind of collaborative progress and process where Zondax is working together with alchemologists and parity. And this started in June. And I will invite now one of the persons that work in this project in our team to go a bit more into the technical details. But the good thing is that he will have some surprises, good surprises. And we hope that in the next few months, this is going to be a reality where everyone in the ecosystem doesn't need to have a Ledger app. The Ledger app will work completely kind of in a generic way for any parachain or any relay chain. That makes this tiny upgrade to the runtime. And this will ensure security, no line signing for anything, and probably no updates, except in some specific cases that obviously software is software. Sometimes we don't know what we don't know. But the fact is that we don't expect that to be affected even by metadata v15. That's our current situation. So now I would like to invite to the stage Fernando. Thank you.
On el clicker. Thank you. Just 1 second. I have to plug a couple of things for the live demo. Spoiler alert. OK. OK. As Juan mentioned, I'm going to explain a little bit the technical details about the generic app for the Polkadot ecosystem. OK. The other one. OK. A brief introduction. I am Fernando. I'm from Argentina. And I have studied electronics engineering. Now I'm working in the security and protocol team from Zondax. And I'm leading the team. And I was deeply involved in the development of the application. First of all, I would like to give a rough explanation about why you have to use or why would you use a hardware security module. And that is like enhancing the security when you want to try, or you would try to sign you try to sign a transaction from any blockchain. The key feature for a hardware security module is to store your private key offline and also to have a secure display to show all the parameters from the transaction. In case that your host computer was infected by like malicious software, the front end could display something different that you're signing, and yeah, your money is gone. In order to achieve like the secure display on the device, the application, the firmware that is running, should be able to interpret and understand everything from the transaction without any third-party information, so nothing from outside, let's say. So the solution that we need for the ecosystem, because of all the mess with the publishing, not just one release on Ledger Live, but many different parachains, is to have one generic application for Polkadot, but it should run for all parachains, or at least most of them. It should support the runtime upgrades, so it doesn't matter if Polkadot has a different runtime version from parachain A, B, or C. And it's also, we are in the bear market, so the cost reduction is one of the key points too. So most of you should know about Substrate, but to give some context to everyone, Substrate provides like basic functionalities. So you don't have to reinvent the wheel every time you want to transfer some tokens from address A to address B. However, you can make custom implementations, and that leads to a lack of standardization. So the same functionality could be implemented in different ways in different parachains. Besides, the encoding, the selected encoding is scale, and there is like one of the best points of scale is like the payload is reduced, is improved on the reduction of the payload, but it's not self-descriptive. So you need to know beforehand what you're expecting, I mean the parameters from the transaction, and how to read and how to format those parameters. So you're just receiving like a bunch of bytes. For the air-gapped devices that doesn't know what is on the chain, that's quite a challenge. And also, it's not just one version, but the issue is after the upgrades. However, we have a secret to tackle this situation, and that is the metadata. Once again, this is, I think, like kind of known for most of you, but the metadata is a specific description for every runtime. So here we have like all the palettes, all the functions and the signatures, and also the custom type that every parachain or every chain could have implemented. Let's go with the real example. This thing over here is what we are going to receive on the Ledger device, and it's, as I told you, a chunk of bytes. So we don't know in which palette we are, in which call. We don't know what to expect on this method. So if we are a step like over here, and we know this path, we can start reading, and OK, we get an index. That index will tell us which type of address we are using for this specific transaction. Then it's, OK, address 20. We have to read an array, 20 times of type n. And yeah, we end up reading some primitive that is a type that we know the size and how to read that. So that's what this kind of logic, like identifying the palette, the method, the types, of the parameters, the inner types, and all that path has to be, or nowadays is fixed on the application, and it's, I would say, different for every chain. So, but I told you that the metadata was kind of the solution to get all this way. However, we have like two big issues with the metadata. The size of the metadata is like 300 kilobytes. For a computer, of course, that isn't any problem at all. However, the devices that we are using has, I don't know, 4 kilobytes of memory RAM, 136 kilobytes for storage. So they are very restricted devices in terms of memory. And the other thing is the one that I mentioned at the beginning. The device and the firmware should be able to interpret all the transaction without any third-party information. So it's really reliable to trust and some external part that is saying, OK, you have to read this like that. You have that many decimals. This is the token symbol, whatever. So, OK, how we approach to get the solution? For the size and for the trust, the metadata will have like a Merkle tree structure. So let's say that G and F, the green boxes, are the things that are not part of the transaction. So let me rewind a little bit. We have the metadata, 300 kilobytes, with some external software. We inject the transaction, and we get like a shorter metadata. That metadata will contain only the important part to understand the transaction. So in this tree, there will be parts like G and F that are not part of the transaction. So we can collapse all the leaves and get that hash. But there will be many parts, not only 3, that's the basic schema, where is the parts of the metadata that we are reading, and we use that to interpret the different parameters. So the app, that's what we do to tackle the size of the metadata, and to make that trust. So we have to calculate the root hash. So we're taking, I don't know, say branch everything that is under C, and we calculate that hash. The same goes for H and E, and we'll start like hashing and getting the root hash. What is that root hash? That root hash is the root hash of the whole metadata, the 300 kilobytes, and that will be compute at build time from the runtime, and that will be embedded on the runtime. So if the metadata is the right one, is the valid, we will end up calculating the same root hash. Otherwise, that will be different. But the key point to trust on the metadata is to add that root hash into the signature. So the signature is not anymore just the transaction, but also this root hash. So this would be like the signing process. From the wallet, you're going to say like a bunch of bytes to the hardware device. But this time, you need to send the metadata, the short version of the metadata, that will be like 5 kilobytes, including the proof, and also the blob that is the information from the transaction. From the metadata, we are going to take like the fields that we need to show and the format from the fields. In this case, from amount, we're going to take amount, the token, the decimals, where to put the decimal point. And from the transaction, the values. In this case, 10.75. That's where the hardest part comes. Ledger currently has like 3 devices, Nano S, Nano S Plus, and Nano X, and we have to support all of them. it's true that Nano S is deprecated. It's no longer for sale, but there are like millions out there. So we take that as the worst case scenario, and we try to make the app work on that device. So yeah, that's we need you to put like 7 kilobytes into a 4 kilobyte device. It's like kind of hard, but we can manage that. After you send the transaction, the device will show you all the output information, and if you accept the transaction, the signature will be generated using the root hat, as I mentioned, and the blob. So let's summarize our approach. The first thing is to define a protocol that should be friendly for offline devices. And friendly is in terms of reducing the size of the metadata and make it more manageable for these restricted resources devices. The second one is safe and secure by design. We're going to have clear signing of all the transactions. We're not going to sign like a hash or something like that. That is probably will not be verified by the user. It's something that a human cannot easily read. So that's one of the key points from the solution. We are adding this metadata into the signature, so we can trust on the metadata. And the security will be on-chain. That means that the node is the one that is in charge to verify if the metadata is valid or not. So also, this approach has not extra computational effort on the node. It's just checking if you need to verify the signature with or without the metadata. Just to oversimplify things, just one if. But yeah, that's it. There were like kind of a hot topic lately in the forum, and they were discussing different approaches, and this is one of the best, I think. OK, for sure, this is like hard to achieve, and there are several parties that are collaborating together. So between Alcymologies and Zondax, we are developing everything that is related to the metadata protocol for the offline signer. And since we need some changes on the node, yeah, Parity is involved to make those changes. OK, for the demo, we have recorded the video, but we like some adrenaline, so let's make it like a live demo. OK, can you record this? Maybe I can the screen from here. No, that one. The device again. OK. The alias. OK, I'm not sure if you can see it right because of the alias, the sampling. OK. Anyways, if you want to see it better, you can approach that after the talk. So we will be sending like 3 different transactions from 3 different chains. The first one is for Polkadot. So this, OK, the camera was changed. OK. Oh, that's so much better. So the first one is Polkadot chain. It's from balances palette, force transfer, and yeah, the parameters. So let's approve this. The second one from state mine, balances transfer, keep alive. The rest of the parameter, approve. And the third one is from Akala. Currencies, update balance. This is quite more complex. Approve. Yeah, that's it for the demo. So. Thank you. So, as you have seen, the parameters are not like, it doesn't have the best UI, UX, but that's why, because we are taking all the information from the metadata, and that is how it's defined on every chain. So let's summarize all the outcome, all the results that we have once this project is finished. We want to have like one application, one ledger application that should support all the metadata that are compliant with the latest standard. So chains that don't upgrade for sure will not work with this application, but the new ones should work. This screen probably you have seen like a lot. Every time we get a runtime upgrade, most of them are breaking changes because of all the paths that I told you that the application doesn't know. So this should not happen anymore unless there is like a big change on the metadata structure. We are more efficient, and we have improved the security. All the parachains should be working on this application, and we are developing just one application, so it's so much better. We have like another incredible result, that is the drastic upsize reduction. So nowadays, the Polkadot application for NanoS needs like 130 kilobytes, almost all the storage from the device. And we expect that to be like 1/3 or something like that. So you should be able to sign any transaction on Polkadot and all the chains, but also to install different applications on your NanoS device. For the rest of the device, it's not the problem, the size. Yeah. Also, the integration for new parachains should be like super simple. If you respect the metadata protocol and you are using the latest metadata, it should be almost out of the box. Yeah, something that is not small is that the cost of the development, the time, the cost of the audit, everything will be reduced. Yeah, will be improved. Yeah, that's it. Thank you for your attention. We are going to follow with the panel, so I invite you guys to join to the stage.
You're a lot more athletic than I, eh? You just jumped here. That's amazing. That's good. Alrighty. Well, thank you guys very much for the presentation. That was very interesting. The moment that the camera was actually focusing on that was absolutely amazing. But anyways, yeah, the idea now is to have a bit of a panel to discuss this. I mean, Fer was telling at the beginning, and I think that Juan also mentioned it, this is not just Zondax doing this. It's like a consortium of different people in the ecosystem that are actually building this entire system, because, yes, ledger devices are very widely spread into the blockchain ecosystem, but the truth is that when it comes to Polkadot, there are a lot of other devices as well that are looking into working as offline signers too. So for that, we also invited Kirill to the table. A lot of people might know him from before, but do you want to do a brief intro about yourself, about Campella as well? And whatnot?
Yeah, so I used to run security at Parity for 5 years prior, and one of the key pillars of that security was Parity Signer, which is now Polkadot Vault, and we had quite a lot of funny experiences in bringing Polkadot ecosystem to work with that. our set of problems was distinct from what Ledger is facing. That is mostly like absolutely hardcore engineering, fitting everything in a small RAM, but with model of updates which allow you to fix the bugs later on. Like, in theory, that's painful, that's expensive, but that is possible. For Polkadot Parity Signer, which is now Polkadot Vault, it is not like that. It is you install it on the phone and you expect it to work forever without any need to go online and update anything on your device. And at best, you need to wipe the device and factory reset it before going online. Otherwise, your key might leak. So we had experience looking at things which work more or less forever. And the whole idea of a metadata being sent to the signer and signer using the runtime interpretation of that metadata to present you the transaction on that fancy big screen of your phone is a fruit of that. And you know that the current solution is sort of like meh, because it requires some party to sign that metadata, and then you have that amazing experience of sitting in front of your screen like that for 10 minutes while the QR video sends like half a meg of signed metadata to your phone through the QR code where every frame fits about 2 kilobytes. Do the math yourself. We invented special crypto primitives for that because we use flavor over Raptor codes. So even if your phone doesn't catch every frame, you can still reconstruct the payload without having to replay the whole video once again to catch the missing one. It is not good enough. It is especially not good enough because Apple stopped manufacturing iPod Touches. And the only way for you to have a secure device with Polkadot Vault is iPhone in airplane mode, which is not widely accepted as the most secure of the devices. Because of that, I joined the Alzheimerologist lab, and we're working on a device I'm going to showcase later today, which is called Campella, which is dedicated hardware wallet. And an important feature of that is that it doesn't do metadata updates at all. It doesn't do firmware updates at all, because you cannot update it. That's sort of like the ultimate security. You get what it is, and it works like your YubiKey would work. You just have it, and it should work. And because of that, we paid more attention in this joint effort on doing things right on the principal level, on the cryptographical level, on getting things which would be future-proof, in a way that also complements the incredible engineering efforts from our peers from Zondax. So yeah, that's the story.
Amazing. Thank you very much for that. That's exciting, and I very much encourage everybody to go afterwards and look into the Campella devices. I think that you guys made a lot of things into the design of it that makes it super, super interesting, and I would very much recommend it. Yeah, I don't want to spoil anything that you might want to share afterwards with the people. But yeah, going back a little bit into the chart that you were sharing there, Fer, and you were sharing, OK, you've got this basic metadata on chain, then we need to strip it a little bit. Why is that compatible with all the offline devices? Why?
OK. No, please.
So the main issue there is that someone can fake or lie when passing the metadata.
Okay.
I mean, what you had before was downloading some JSON that you hope is coming from the trusted node, but when you send that through a USB cable, even in that case, or whatever QR code, you could lie there and you could send a different type or different things. And actually, what you show you take that metadata as a way to feed your parser, and then you show something that is incorrect. So the thing is, we didn't want to open that door to exploitation. And when you are offline, there is an additional case that is that you don't want to get, as Kirill was saying, updates. So even in the case of exchanges or people that have kind of offline devices, Ledger, whatever, there was still this big open point of how can I decode things and trust what the node is telling me? Because everything should be untrusted. And I think that the fact that now we have the ability for the node to kind of verify that the metadata is correct and that we close that gap there, at least I have not seen that in other projects or in other ecosystems. And I think that will help for anyone that needs to do that needs to check before signing what is actually signing. in a trusted way possible, that it was not always possible before.
Yeah, you said something quite interesting at the beginning as well, and you told me after, before that too, that this metadata, this verifiable metadata process is working sort of like a verifiable ABI that people are used to in other ecosystems. And you haven't seen that. I mean, you guys work with a lot of different ecosystems. You haven't seen that across, right?
Yeah, typically, when you want to decode something, you need to trust that the ABI is true, or you just like sign a hash. It's basically that. Or you have to go through an audit and you just write hard-coded software that is like following the ABI. But there is this gap there. And this was not that bad when you have immutable smart contracts. But when you have runtime upgrades, that the only source of truth is actually the runtime wasm that is on chain.
Like, I want to spin it in a different way once again,
Okay.
the different nature of a product. If you think about what your transactions should look like on any blockchain, not like necessarily like Polkadot or any substrate based, you want it to be as compact as possible. You want to use minimal amount of bytes to express what you want to say to the chain, because that will be replicated on thousands of nodes forever. That's incredible cost to the planet in the end to have it larger than you need. But at the same time, people are really terrible at reading the hex dumps of some bytes and making meaning of them. People want to have semantic meaning of what they're signing. And you need a way to transparently translate one into another in a way you can trust. And this is essentially what metadata is. It's a dictionary. It's like a phrase book going from like a world of compact bytes and encodings to a world of like people actually reading things. But all the projects we observe, they evolve, they change. And those dictionaries change. And the solutions which require hard coding a dictionary and calling that a day, they're not future-proof. And we want solutions which are future-proof for the price, for the engineering cost, for the just reducing e-waste reasons.
Well, it's not. I would add to that as well, and this less trust component too, that the dictionary could be fake too, right? I could be telling you this bytes actually represent this other thing, and you're signing something that you don't really know, right? So from this entire process, the way that I get it, and I hope I'm getting it right, is that there's some parties that are actually doing all the translation into the device, and then that transaction is sent, but then it's the chain in the ultimate instance that says, yes, this was translated with the right metadata, which is this root hash that Fer was talking about. Is that correct?
Have you seen that sketch from Monty Python about like a bad Hungarian phrase book?
No.
Where the guy wants to buy tobacco at the shop, but he actually says that his hovercraft is full of eels. Okay. That's a legitimate attack with a fake dictionary.
Exactly.
And like, yeah, you can trick people to transfer like 300 dots instead of 3 dots by telling them the different amount of zeros you need to chop off. Or you can trick them into swapping the destination and the target addresses or things like those. They're all possible, and you need to trust your dictionary vendor to actually be able to process that. And where does that trust come from? And yeah, we have the ultimate thing which allows us to manipulate trust. Those are called blockchains. Maybe you can use that. And I was like, yeah, we teach our transaction to commit the particular version of a phrasebook in a verifiable way. And the blockchain will check if that phrasebook is legit. And if it's not, then it doesn't matter what I've seen on the screen and if that was something I sort of wanted to do. Because the phrasebook I used was incorrect, and I have a poor Hungarian guy from a sketch you can find on YouTube, and that shouldn't be accepted by the blockchain. And thanks to flexibility of the substrate, thanks to flexibility of the ecosystem we developed, we can relatively trivially to upgrade to this, to the format of transactions which commit to the particular way you present them to people. There is no other ecosystem which is flexible enough to carry that out, as far as I know. And like, yeah, if you are in the engineering of some of the parachains, you probably need to pay attention and you need to play along, because that will empower you out of the box to use your blockchain, your parachain, with whatever Zondax is building, whatever we are building, whatever Parity is building.
Yeah, that's very cool. That's very cool. Now, writing these dictionaries is not an easy task either, right? This metadata. And you've been already playing along with this for a long time. You've been experiencing with a lot of different parachains and whatnot. And in the end, and you also mentioned this too when you were presenting, is the UI UX of this is sort of bounded right now to the way that this metadata is actually scripted, okay? Because yeah, of course, there's no actual other translation than that after it, right? And I know that there have been some discussions about doing using maybe some of the docs that come with the metadata and whatnot. So I was wondering, yeah, what are your thoughts? What are your recommendations for builders in the ecosystem? Things that they might pay attention to so that this becomes as humanly understandable as possible, right?
Yeah. I think that you summarize everything. So the app should work for all the parachains, but there is a responsibility on every project to make that as more as human readable as they can. If they just the naming convention is awful, like transfer 1, transfer 2.
Yeah.
Okay, the experience from the user that had to sign that it will be awful as well. I just to rewind a little bit, the thing that you mentioned, because we were creating all the tests to try this, we kind of messed up and used like a fake metadata with the wrong parameters. So yeah, that would be like super easy to fake, but then the security will be on chain and the transaction will never be valid. So in the end, the user is just lose some like a minute to sign the transaction, but the blockchain will reject that. So that is something super nice and important to remark.
That's cool. I don't know if you have anything to add to that.
Yeah, like I would avoid naming and shaming, but so I will take it from the Pirates experience first and foremost. In the governance one, the votes in the transaction like read like variant 127 and variant 1. You are free to make out of that whatever you want.
Yeah, exactly.
In the governance tool, there is really nice information in the metadata which says that vote abstain and other things, which makes sense to the human reading it.
Yeah.
And so that means that A, it is possible to express what you want in a concise but explicit way. B, it is possible to update. And like C, just give it a little bit of the thought because, yeah, once again, not naming and shaming session, but if you know that your project is adding like quite a lot of NFTs and everything to the balances palette out of spite, don't do that. That really makes our life so much harder.
Yeah.
Just for context, I mean, before, when we were like doing these upgrades for Polkadot or Kusama, we were doing that kind of work manually. I mean, we were looking at the metadata, trying to understand in the code what was happening and put something that sounds friendly. But that's also error-prone. I mean, we want the developers to take care about their own like, kind of variable names. I mean, what we probably will see in the next few months is that there will be a kind of like cleanup in the code of the parachains and actually in the palettes. We have not seen anything like, okay, the parameter is X and Y, but maybe there is something like that around.
Yeah.
So this is something that this is a process. I mean, we are building with Kirill and Campella the metadata kind of infrastructure and the apps and everything, but it will take a bit for everyone to catch up and to go back to kind of like something that any user can understand in an easy way. I think in Polkadot and Kusama it will be like almost like smooth, but
Fingers crossed.
yeah. We are like kind of like planning to create maybe some kind of like a test generation tool where you can see the outputs for your chain or things like that. But in the end, the responsibility is on how clean your metadata is.
Yeah. So I maybe would like to use this opportunity to do a bit of a shout out to both developers and people using these offline devices as well to sign with this new process whenever it comes to live and to report the things that they say, right? That they see. So maybe if I'm going to sign a transaction and I see that it's not very clear to me, I could reach out to the team and say, hey, this is not very clear. Maybe you guys can change something or what. And developers themselves building these parachains, building these runtimes, Polkadot and Kusama too, can look into being a lot more attentive into these things and making sure that, okay, whatever I put in here is in the end what's going to be appearing on the screen of a user. Ledger screens, nano-OSs are like this. Campellas are a lot bigger and nicer maybe, but still the space is limited and we need to cater for these people and for them to understand basically what they're going to sign, right?
But by the way, this thing out of the screen, obviously, we don't know exactly when, but you can see in Twitter some videos of the same demo in Stacks, which is already working too and is going to be out there.
Definitely, I saw that too.
I was reaching out just to clarify. I mean, once the generic app is out, we're a bit out of the game. I mean, it's about fixing the metadata of the parachain.
Yeah.
We will not have control over what is being shown. We will show what the metadata says that it should be shown.
Yeah. I have sort of like two last questions here to iterate on some points, and then maybe we can open it some questions if we do have the time. But the first one is, you were talking a lot as well about, okay, with this process now, runtime upgrades are almost seamless, right? I mean, yes, of course, it could happen that we need to upgrade these apps for a reason, and that's okay. Things can happen. This is software, as you said, Juan, before, and anything can happen. But in an ideal case, in a theoretical case, if a chain upgrades at runtime, this app continues to work, right? Why?
Because runtime upgrades means metadata changes, and that was hurting us.
Okay.
But now, if the metadata changes, I mean, basically you can stream the new metadata to the device. There is, I mean, maybe we didn't go like so much in depth, but the idea is that the metadata that is on the node is like Merkleized. We will provide like some very kind of like small library. I mean, it will be like kind of like everyone in the community will be able to kind of do that because it's a standard that I think is going to be published in the fellowship repository. But the idea is that you get the metadata. If you know what transaction you have a short-term metadata that is like only the pieces of the tree that you need, and that's what you send. So, I mean, you change the metadata, you change the runtime, we don't care. Basically,
exactly.
That's the cool thing.
And this basically means no need to wait to deploy these apps again. One app that works for the entire ecosystem, not different apps. I mean, if I think about it today, even if I were to use all the different apps in the ecosystem, in Ledger particularly, one Ledger device is not enough because the app itself is quite heavy, and I need at most I can fit 2. And then if I want to use more parachains, I need to have several devices. Yep. This is one app that works for everybody, for Polkadot, for Kusama, for all the parachains in there, and does not need to be updated on each runtime upgrade. So therefore, every single change that teams do are automatically out there to be signed with all these offline devices, which I think it's very, very nice.
I mean, we will need, and also the community, all parachains, will need to have a kind of like a coordinated effort on telling users, because at some point someone will go and they will not know that they need to use the Polkadot app, and they will say like, oh, where's my parachain app? It's like, I don't know, where's my money? And
yeah,
so I think the Polkadot ecosystem as a whole needs to be communicating this properly to users.
I fully agree, but I think that at the same time, this is an amazing experience from a user perspective, right? Because in my personal opinion, using any parachain is using Polkadot too. So in the end, when you're using the Polkadot app, you're signing anything that happens in the Polkadot ecosystem, even smart contracts on top of chains, anything that might be, right? So it's quite of an interesting, like, okay, family thing that's happening with this one initiative. I want to finish with the question, when this is going to happen? Which I think it's always a very tricky question to answer, but more than when, what are the next steps here, right? Like, what are the things that need to happen in order for this to be active for the community to use?
I may try to answer that.
Go for it,
I mean,
please.
Again, software is software. So, as I said, there are different streams of work. There is this stream of work that Campella is doing, about like kind of finalizing the specifications. We contribute to that, but we need to finalize how the proof is going to be kind of defined, because we don't want to change that anymore. So there is a lot of really strong and important work there. We are finalizing the apps. Then we need like parity to make the modifications in the node. That needs to go into a chain that carries value, so we can run an audit and a functional review with Ledger. Then the app will go public, and because we are going to use a signing extension in the runtimes, parachains that want to get this functionality, they will need to enable this signing extension in the runtime. So, I mean, when I would say a few months, it depends. I mean, we all know Christmas is kind of like a very interesting time, but at the same time, people go on holidays. So, I mean, there is, but a few months. And later, in my opinion, there will be a kind of transition time for parachains to catch up, wallets to start like adding functionality, I think that there will be a kind of like time where things will start moving. But as soon as the app is there, anyone can just like make this minor effort and get it out.
That's amazing. That's very good. These are my questions for you guys. Thank you very, very much for your time. But we do have some time left, so I'm wondering if anybody in the audience has a question. I see some hands raised. So yeah, I don't know. Whoever you guys want, it's fine.
First of all, guys, thank you. Because we're working on a protocol to connect wallets to dApps, and we have the same exact problem, and we searched it like a lot in ecosystem what to do. We try to reduce metadata. Yeah, it works, but how to validate it, it's a problem. So really thank you for this functionality. I hope it will be soon implemented by Polkadot Kusama so we can use it. And please tell me after this where I can find docs and specifications. Thank you, guys.
Yeah. I can attempt to answer that. So on the Alcymologist repository right now, there's all the project description. There's like even milestones and everything that you can follow. And all of these things. I know that the Zondax, particularly, I'll give you in a minute. I know that Zondax particular repo is right now closed source because it would be quite risky to deploy this and people to start using this, given that the actual code is not implemented on Substrate yet. But the rest of the project can be followed there, and we're more than happy to share it. You were going to share something as well.
So we are moving on a milestone basis, like we always do, and like this is the way for us to get more community trust that we are not going off track. And it is important for us not to publish a spec before it's ready and validated by the team like Zondax, because otherwise you would commit to it. We see what is not working together. The next milestone would be exactly publishing the spec. And if my memory serves me well, it is 2 weeks from now. At that time, there will be an official document. Of course, unlike Zondax, we don't risk that much by doing things in the open. So if you want to play around, in the Alcymologist GitHub repo, there is the substrate parser, which is like a library which also powers the Polkadot Vault in the way it represents the metadata right now. And there are pieces of code which can be used to play with your chain, see how that chunking is working, and so on. But as far as I remember the status, we're currently working on the last moving pieces about the Merkle tree specification.
Yeah.
Because we want that to be as compact as possible. But it feels to me right now that the very, very straightforward Merkle tree is the optimal way of doing that, because we can optimize, but all the optimizations we tried end up to be over-optimized on a very particular use case, and all 100 other parachains wouldn't benefit from that, and it will make things worse.
Cool. We've got time for one more. Yeah, you guys decide who wants to go. Whoever gets the mic first. All right, Joseph won. But still, I mean, you guys can find them afterwards and ask whatever questions you want. It's fine.
Sorry. Feel bad. First off, thanks a lot. This is amazing. I'm super excited. And again, thanks a lot. I know the question I'm going to ask is a little bit like pulling for straws, but it's meant maybe to clarify or perhaps to think a little bit about this. The data that is displayed on the ledger for the user to sign is the cold data, right? But there is more stuff that is being signed that it kind of, at least one of the rest of the stuff that is being signed in the signed data, perhaps one of those fields should also be displayed to the user, which is the tip. Oh, so sorry. Don't you think that perhaps displaying also to the user the tip that they are bound to sign could make things more secure?
Yes. And so far, we have removed a couple of the fields to make the presentation simpler. But yeah, in all Zondax applications, we have an expert mode, a normal mode. The tip belongs to the normal mode, so it should be there always. But we finished implementing the decimal points and the token symbol last week on Friday. Yeah, on the expert mode, you will see the Genesis hash. There are, I don't know, 3 or 4 parameters that might not be relevant. But if you want to see everything related to the transaction and the chain, you could see that.
Yeah, I was pulling for straws. I was thinking of a possible, you have been compromised, and I'm going to send a transaction to a node that I control, and I'm going to add like a humongous tip, and like, it's super random, but theoretically, but really cool. Like, sorry, I didn't see it there. And,
yeah, that part is not kind of affected by the metadata, but obviously by the kind of like external part, not just the code. We typically do, I mean, in the previous app, we had that. I mean, right now we have concentrated on the metadata, but we will bring that. And actually, what you are saying are things that happen sometimes during audits where people describe these things. So, for example, one of the things that we have in some scenarios is that when you have like very strange values, we trigger expert mode automatically. So, for example, in this case, I mean, it's good feedback. We can say if the tip goes over a certain value, we show everything. I mean, in some places it doesn't make sense because it's like too much information, like showing. But for example, in this case that you are describing, we can say put a boundary over 100 something and then go for expert mode.
Yeah, well, the tip is one of the sign extensions that it's in the metadata. But we're on the same page. It's really cool. Sorry, thanks. This is amazing.
On compiler side, we don't have that problem. We have much more screen than Ledger devices allow.
Yeah.
So like you see everything, you want it or not.
Amazing. All right, so this is the time for us. Thank you guys very much again. I encourage everybody again to go and listen to Kirill about Campel afterwards. I'm very excited about the device, 100%. And also engage with the Zondax team if you have any further questions or anything to ask. I think that this is an incredible thing that's happening, a real problem from the ecosystem being solved by the ecosystem as well, all funded by the treasury. I mean, this is the dream, right? So thank you guys very much for all the effort. And yeah, hope to see more exciting news soon, I guess. All right.
Thank you.
Good. Yep. Thank you very much. Yeah.